Hey guys, welcome to this video on the 2019 Level 2 Electricity and Magnetism paper for physics. So question 1, the bicycle lamp. Jason needs to buy a lamp for his bike. When he pulls apart an old lamp, he finds some circuits. A simplified version of a circuit found in Jason's bike lamp is shown below. A, the voltmeter reads 4 volts, show that the circuit current is 0.8 amps. Alright, so in the circuit, as you can see, there's only one pathway for the current to flow, which means that it is a series circuit. And in series circuits, some important things to note down is that the current is constant, but the voltage is shared between components. That means the current going through this resistor will be the exact same current going through the 5 ohm resistor. So using this, we know that the voltage through the 5 ohm resistor is 4 volts. And we know the resistor of the 5 ohm resistor. So we can use the relationship of V equals to IR in order to find our current. So we know our voltage is 4 and our resistance is 5. We can rearrange to find our I, which is 0.8 amps. And a justification sentence, you could say in series, current is constant. And this would net you, once again, I was saying this for my level 2 math videos. I don't have the marking schedule, so I don't know how NZCA is going to mark this exam paper. However, I can give advice on a rough idea of how the exam will be marked. So, and roughly, this should just be an achieved mark here for working this out. Alright, B. Calculate the heat energy dissipated in 2 minutes by the resistor marked R. So we want the amount of energy that is dissipated by resistor R. So we know that E equals to, better way to put it first is P equals to change in E over T. So therefore, E equals to power times total time. We have the total time as 2 minutes. 2 minutes, remember we have to write everything in terms of seconds. So 2 minutes, that equals to 120 seconds. So we have our time, but we need to find our power. So in order to find our power, we can use P equals to IV. We have our circuit current is 0.8 amps, so we need to find the voltage used by the resistor marked R. We know that the voltage supplied by the battery is 15 volts and the voltage used by the 5 ohm resistor is 4 volts. In series, we know that voltage is shared, which means that the total voltage used by all the components should be equal to the battery voltage, supply voltage. So if 4 volts is used by the 5 ohm resistor, that means that 11 volts, which is the 15 minus 4, so 11 volts must be used by the resistor marked R. So you can say voltage shared in series, hence resistor R is 11 volts. So hence resistor R. Alright, now we can use our relationship between P equals to IV. So P equals to 11 times of 0.8. And that should give you an answer of that should get you an answer. It should give you an answer of 8.8 watts of power. So 11 times 0.8, that's 8.8. And now we can use our relationship between energy, power, and time. So we can say E equals to 8.8 times by 120. And that should give you an answer of 1056 joules. And that should be your final answer. We forgot the unit, so joules is J. So that should be your final answer for this question. And in terms of this question, this should be a merit level question. In order of getting an achieved, I'm thinking if you find the voltage used by the resistor marked R, you should get an achieved. Alright, another part of the circuit in the lamp is shown below. Calculate the total resistance of this circuit. So in this circuit, we're shown a parallel circuit, but there's a series circuit within the parallel circuit. So we have to identify the circuit, so we can see the 6 ohm resistor and the 5.6 ohm resistor are connected with each other in series. However, the 6 ohm resistor and the 5.6 ohm resistor are connected in parallel with the 3.2 ohm resistor. So we can say we can call this pathway 1, and we can call this path 2. So we have to use our relationship between the total resistance of a parallel circuit. So that's 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3, etc. Where R1, R2, R3 are the resistance of each individual pathway. So this is R total for series, and for a parallel circuit, R total equals to R1 plus R2 plus R3. Alright, so for this question, we have to find the combined total resistance of pathway 1, and we can use the relationship between the parallel circuits in order to find the total resistance. So we can say that R pathway 1 actually, R path 1 equals to 6 plus 5.6, which equals to 11.6 ohms. And the path 2 is 3.2, so we can R path 2 equals to 3.2 ohms. So now we can use our relationship between our resistance in parallel and to find our total resistance. So 1 over R total equals to 1 over 11.6 plus 1 over 11.6 plus 1 over 3.2. And by using a calculator, so 1 over 11.6 plus 1 over 3.2, and the 1 over your answer should get you your resistance. Your resistance should come out to be R total is 2.51 ohms. And by getting this final answer, there should be another merit level question. Oh no, merit level question. In terms of getting it achieved, if you can, maybe if you can add this up, I'm not sure. This might be an achieved. If you find 11.6 ohms by finding the total combined resistance of pathway 1, that might be an achieved. Alright, D. Jason's friend Deborah designs the following lighting circuits, and Jason wonders which circuit will give out the most light. All lamps are identical. Circuit 2 has an extra lamp. By considering the combined brightness of all the lamps in the circuit, give a comprehensive explanation comparing the total brightness of circuit 1 to circuit 2. Alright, so circuit 1 has one less lamp in parallel than circuit 2. So once you add the extra lamp in circuit 2, that's adding an extra pathway in a parallel circuit. By adding this extra pathway, we're giving one extra pathway for current to flow, which means that the total resistance of circuit 2 will actually decrease. So this resistance of circuit 2 is going to go down. And assuming that, this 12 volts is the same, so the voltage supply is the same, so voltage is constant, therefore V equals to IR. Resistance goes down, voltage stays the same, which means current must increase. So the circuit current of circuit 2 would be greater than the circuit current of circuit 1. Okay, so a more simple way to look at it is that if there's more current being drawn from the battery, and the voltage of the battery remains the same, you can say P equals to IV. The current has increased and the voltage has stayed the same, which means that the power output of the battery in general must increase. So the battery is giving out more. You're drawing more current from the battery. So therefore, as the voltage stays the same, the total combined brightness of circuit 2 will be greater than circuit 1. So some important points probably to cover in this question, you could say, by adding extra, I'll just do some bullet points here. So by adding extra lamp, by adding extra lamp in parallel. circuit resistance decreases. Circuit current decreases, extra pathway for current to flow, and a voltage stays the same. Because voltage stays the same, V equals to IR. Hence, I is inversely proportional to R. Hence, as R. Okay, so more current drawn from battery. Hence as P equals to voltage stays constant. Hence voltage stays constant. Hence as current drawn increases, the combined will be greater than the combined resistance combined resistance of circuit 1. So that's pretty brief. So if you read the question, so by considering the combined brightness of all the lamps in circuit, I think that if you want to go one step further, you could compare the each individual power outputs. You could compare the power output of this lamp with the power output of this lamp in circuit 1. And you can compare the brightness of the circuits, the lamps in the parallel with the circuits in parallel of the other circuit. I don't think it's necessary because it says by considering the combined brightness of all the lamps. So you're considering this total brightness, so compare the total brightness of circuit 1 and circuit 2. So this explanation has compared the total brightness. So I don't think it's necessary, but if you wanted to compare the individual lamps, that would be okay as well. So I'll do that as well. So alright, so thinking about this way, so we know that the total current has increased here in circuit 2, and in series current stays the same. So in current it stays the same throughout the components. So this lamp in series will have I total flowing through it. So hence, as the total current has increased in the circuit, this resistance will stay the same. So V equals to IR. V equals to IR. Current increases, resistance stays the same. So the voltage of this lamp will increase. And also we know P equals to IV. So both voltage and current has increased in the circuit 2 series lamp. So hence the circuit 2 series lamp will be much brighter than the circuit 1 series lamp. So this circuit 2 lamp in series will be brighter than the circuit 1 lamp in series. In terms of parallel, in parallel it's a bit harder. It really depends because in the circuit 1 we had an I total, which split so half of this, because these bulbs are identical bulbs. Where does it say that all lamps are identical? So therefore, when this I total reaches the junction, one half will go upwards and one half will go downwards. So basically, this lamp will receive one half of the total current, and this lamp will also receive one half of the total current. However, in this second case, we have an increased I total, However, there's now 3 pathways, 3 identical lamps. So now it will be splitting in 1/3 of I total, and 1/3 of I total here, and 1/3 of I total here. So it really depends on how much the current has increased, which gets a lot more complicated, right? So if we say this is R, so okay, there is a way to do this. So R, everything here is R. So R total is 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R total, so let's go down here. So 1 over R total equals to 1 over R plus 1 over R plus 1 over R. So 1 over R total equals to 3 over R. So basically 3R total equals to R. Yeah, so R total equals to R over 3. And then plus the resistance of the lamp in series. So this will be the total resistance of the circuit 2. And as for circuit 1, we have this similar, except we have 1 less R. So 1 plus 1R, 1 over R plus 1 over R, which is 2 over R. So 1 over R total equals to 2 over R. So 2R total equals to R. So R total equals to R over 2. So for the circuit 1, it is there is a difference. So this is also R total plus R due to the lamp in series. So the difference between this is, so R 1/3 of R minus 1 1/2 of R here, and 1/3 of R here. So 1/2 of R minus 1/3 of R, that is 1/6 of R difference. So that's the difference between the circuits. So in terms of the current, so V equals to IR. Okay, so we know voltage is 12, stays at 12 equals to I and 1/6 of R greater, so 7 over 6. Whew, it's pretty tough actually. I might do something incorrectly here. R over 2 and then R over 3. So yeah, difference is 1 over 6R. One over 6, so okay, I think we should not do the difference, but instead we can do as a fraction. So how much percent has it decreased might be a bit better. So 1/3 over 1 over 3. So it's decreased by 2 over 3, so this equals 2 over 3. Wait, so 1/2 times 2 over 3. Let me just check this. Yeah. So it's decreased by that equals to 2 over 3, but it's decreased by 1/3. Okay, so it's decreased by 1/3 of it used to be. So it used to be So now it's 2 over 3 of what it used to be. So yeah, that's right. So 12 divided by 2. Sorry, just say this is constant. We can just say this was 1 because it's constant. So 1 over 2. Okay, so current will increase. Current increases by 1.5 times. Increases by 1.5 times more. So because it increases by 1.5 times more, 1.5 times more, so this will be 1.5 I. So this will be, okay, so the current flowing there will be the same, but, okay, so we had, okay, so basically in simpler terms here, we had I total here, and this circuit 2 had a 1.5 I total because it increased by, this is 1.5 times greater than the I total in circuit 1. And because it splits evenly at the junction, so each junction will get 1.5 I total. This junction will also get 1.5 I total. This junction will also get 0.5 I total. And in terms of this one, so this one is just 1 I total. So once it splits here, so each pathway will also get 0.5 I total. And this will also get 0.5 I total. So that means the current flowing through each lamp is the same. However, we have to find the relationship between the voltage. Remember how I was saying that the voltage used by this lamp in series has increased? Because this bulb in series has using an increased amount of voltage, and the voltage is shared between the components in considering this is a series, so this is one component and this is one component. So the voltage in series is shared. So if the voltage in the bulb in series has increased, that means the total voltage of the bulbs in parallel will decrease. So this will all be experiencing the decreased voltage because voltage in parallel is the same. So all of these bulbs will experience a decrease in voltage, and as P equals to IV, that means as the current stays the same and the voltage is decreased, that means each lamp in the parallel, each individual lamp in parallel will be less bright than the bulbs in the parallel of circuit 1. So the bulbs in the circuit 1 in parallel will be more bright, so these will be increased power. However, the bulbs in the parallel of circuit 2 will have less bright because it's decreased power. So basically, in conclusion, in circuit 2 does have an overall greater brightness. However, the brightness of the series bulbs, circuit 2 is brighter, and for the parallel, circuit 1 is brighter. Okay, sorry that took a while. It was I don't think you didn't have to do the very in-depth details. I just think all you had to do was comparing. So this part here, I think, was the most important in terms of the grading for this question. But in overall, I think you should get an excellence grade in order if you compared the currents. Sorry, not currents. If you compare the brightnesses correctly, you should get an excellence grade. To get an achieved grade, just to get an achieved, I think you can identify that the resistance of circuit 2 has decreased. That's an achieved. And a merit could be you could have deduced, for example, maybe the current has increased, or maybe that the total power used by the bulb in series is greater. Something like that might get you a merit grade. So yeah, I'm not too sure. Alright, sorry about that once again. Took a while, but we got there at the end. So question 2, a model space rocket. Manu thinks that he could use an electric field in space to slow down a rocket ship. He models his idea by setting up a pair of parallel plates 1.2 meters apart. He connects them to a 550 kilovolt supply and uses a small rocket as a trial. The mass of the toy rocket is 130 grams. The rocket moves from left to right, and the charge of the rocket is 3.5 times 10 to the power of negative 6 coulombs. Calculate the strength of the electric field between the plates. So we know that the electric field can be expressed by the relationship of E equals to V over D. E equals to V over D, and hence we can say E equals to voltage is 550 kilovolts. Remember, kilo is times by 1,000. So this is actually equal to 550,000 volts. So 550,000 over the distance, which is 1.2. So that should give you an answer of, that should give you 458,333.33 volts per meter. And that should net you an achieved grade. During one test, the rocket was initially moving at speed v and was stopping in a distance d. Explain in depth what happened to the stopping distance of the rocket was tested again at double the initial speed and the same charge. So the important thing to note down in this question is that by increasing the double initial speed, we are actually increasing the kinetic energy of the rocket. So this is an energy conservation question. So it's asking you, how is the distance traveled affected by the speed? So distance affected by speed. So we know that EK equals to half mv squared. So half mv squared, and we know that the velocity has been doubled. By doubling the velocity, we are actually increasing the kinetic energy by 4 times. And the reason for this is because the relationship is v squared. So you can think of it this way. So it says double the initial speed, which is 2v. So we say EK equals to half m 2v squared. Well, sorry, not exactly. So if we say, EK equals to half mv. If we replace v with 2, we can say 2 squared. And 2 squared is 4. So basically it will become, EK will increase by 4 times, not 2 times. So if it was a 3, so if we said that let's say that the rocket was tested again with triple the initial speed. So it will just become EK equals to half we'll say 3 squared this time. So this time the EK will increase by a factor of 9. So in this case, we know that the EK has increased by 4 times. So EK becomes 4 EK. Kinetic energy increased by factor of 4. Alright, so now we're going to be using our energy conservation. So we say assume energy conservation. So EK equals to EP. So we know that EP equals to EQD. We know that the charge of the rocket stays the same, and of course that the electric field strength will remain the same. So we know that the EP is increased by 4 times. This electric field strength stays the same and charge stays the same. So therefore EP is proportional to D. Hence, as EP increases, sorry, that's really messy. As EP increases by 4 times, the stopping distance also increases by 4 times. And getting up to here, I think, should be a merit grade. In terms of getting an achieved grade, an achieved grade could be finding out the relationship between the EK and the half mv squared. So if we find that by increasing the velocity by 2 times, we'll get quadruple the total kinetic energy that might be achieved. Alright. C, draw the field line between the 2 plates. So field plates is always a positive to negative. So we have our positive on the right and our negative on the left. So our electric field lines are going to be going from right to left. So once again, important things to note down is straight lines, equal distance, and curved lines. So if I did, it should look something like this. My drawing on here isn't going to be perfect because it's pretty hard to work with a digital device, but roughly should look something like this. So we have our electric field lines. It should be straight and equally spaced. And obviously do not forget the curved lines, so curved. Okay, sorry. It should look roughly something like this, and getting everything. So basically, things to note down is curved lines. Curved lines for the two on the end, so curved lines, and we have straight lines for the ones on the plate, so straight lines. We also have equally spaced. So all three of these should get you a merit grade. And in terms of getting an achieved grade, I'm thinking if you miss out the curved lines on the end, you'll get an achieved. So if you miss out this one, you'll get achieved. Alright, the maximum stopping distance for a given setup is 1.2 meters. What is the maximum speed that a rocket can initially be moving and still be stopped by this apparatus? So we know that the stopping distance is 1.2 meters. We know that our charge was 3.5 times 10 to the power negative 6. So our charge is 3.5 times 10 to the power negative 6 coulombs. And we also know that our mass of the toy rocket is 0.13 kg. And our electric field strength we also know is 453,333.33. Double check that. No, it's 58 actually. Wow. Alright, so now we can, this is really similar to question number B. So it's once again, it's energy conservation. And we can use this by finding out the EP, and then using EP equals to EK to find the maximum speed. So EP, we know equals to EQD. So therefore, EP equals to 458,333.33 times 3.5 times 10 to the power negative 6 times by 1.2. And that should give us that our EP is equal to 1.925 joules. And now we can say that EP equals to EK. So EK equals to half mv squared. So 1.295 is equal to half of 0.13 times of v squared. So your v should come out to be v equals to 5.44 meters per second. Is a maximum so in order for the rocket to be stopped, that is the maximum speed that it can be traveling at. So basically this should get you an excellence grade. In terms of finding an achieved grade, achieved grade could be finding the EP stored. That could be an achieved. And I'm not too sure where you can get merit for this question, but yeah, I'm not too sure. So because I'm not too sure, I'm not gonna say anything, just in case I say something that's very incorrect. Alright, so thank you for watching this video for question 1 and question 2. I will be posting question 3 shortly, so stay tuned for that one. Alright, thank you for watching this video, and I'll see you all in the next one. Thank you.